elevations. And over a 100-year period, which is a lot of time to do this, you know, we slowly turn all of the mega buildings up to highland, and we convert Lower Manhattan into park space. We let it flood periodically with a storm surge on top of a sea level rise, and we're good. So, you know, it makes a little bit of sense, but we have to think about these things now, guys. And these, I mean, these are things I hear in my Earth and Atmospheric Sciences. It's not, you know. So anyway, move New York City, move Cape Canaveral. You know, it's going to cost a lot of money to move all these things, by the way. Arctic sea ice loss. So the Arctic's warming twice as fast as the rest of the planet, the lower latitudes. And this is a graph of I should make these sometime. Someday I'll make them bigger, but you don't really need to know. This is like the millions of square kilometers of sea ice. We have satellites that can measure the spatial extent of the sea ice over the Arctic Ocean. And we've been doing it since the late 70s. And it's so many millions of square kilometers. And I think you can see that over the many decades, we've got this downward trend. Every summer, the sea ice shrinks back, and every winter it expands back out fully out to all the Arctic Ocean. And the summer it shrinks back, but every summer it shrinks back more and more and more. And so this is the summertime minimum sea ice extent. You can see that it's gone down, down, down. 2007 and 2012, the sea ice shrank back so much that the fabled Northwest Passage opened for the first time in human history. Wow. And this is called, you can't see all the nice colors here, but we, you know, this is the Arctic Ocean, and how many people have heard of stories in the news about Russia plants a flag on the bottom of the Arctic Ocean and claims it for Mother Russia, and Denmark, this is the territory of Denmark, Greenland, and Denmark is now putting navies up here. Canada now has added more navies, in the US and Russia are now making these major military repositions of militaries up into the Arctic Ocean. Just about a month ago, Russia announced a major military realignment into the Arctic. The US has been doing such, not quite as dramatic, but has been doing that as well. And the big deal is twofold here. There's a lot of oil on the bottom of the ocean in this Arctic. You can't drill it when all the ice is flowing around and breaking up. It'll knock oil derricks over and all that kind of stuff. But if there's no ice there, then you can set up an oil drilling rig and drill a bunch of oil. It's also kind of like the Suez Canal. It'll make shipping lanes to take ships from the Atlantic to the Pacific, or from Europe to Asia in a quick sort of way. So a lot of people are claiming, Canada says this is our shipping lane, you're going to have to pay us just like you pay the Panama Canal or the Suez Canal. America is saying, no, it's international waters, and nobody gets to charge anybody anything. Anyway, there's a lot of pushing and shoving because of this. So they wouldn't be doing this if there wasn't real data behind their ideas of what they have to do. The military's not that dumb. So IPC, this is the fourth report, so I'm cheating a little bit here, but this is the IPCC's projection of the summertime sea ice extent to the end of the century, 2100. And they're like, we're still going to have quite a bit of sea ice by the end of the century. But observations, these are the observations, and many glaciologists and climate scientists now think that the summertime Arctic Ocean will be completely ice-free by 2030. In 15 more years, we're going to get a summer condition where we'll be completely ice-free. And this is where I really freak everybody out, which is to say that, you know, when you guys get a little bit older and you have kids, which might seem weird right now, but, you know, I tell the college students at Cornell, I go, you're like this close to having kids, and your kids are going to look at one of these globes, you know, that are in the classroom, and they're going to go, Mommy, Daddy, why is the top of the ocean painted white, you know? And you're going to say, well, that's because we used to have ice cap on the top of the planet until just, you know, last 20, 30 years or so. So these are things that are changing. And I want to point out that these are not somebody else's problem down the line. We're in the middle of it right now. So these are problems that are right on our head. Coral bleaching. Corals are animals. They have tentacles. They have a mouth and a gut. They eat zooplankton that swim by. And they also secrete a calcium carbonate not all corals, but a lot of the corals that you think about as coral reef kind of corals make these hard protective substrate out of calcium carbonate. And that'll turn out to be an important fact when we talk about ocean acidification. Calcium carbonate dissolves in acidic conditions, or minimally it's hard to precipitate calcium carbonate under more acidic conditions. So corals can be impacted by acidity by this particular fact. Corals are animals, they have tentacles, but they also have this very important symbiotic relationship with an algal called the zooxanthellae. And all of the beautiful colors that you see in coral. How many people have snorkeled on coral reefs, by the way? So all the beautiful color you see are the color of the zooxanthellae algae in the tissues of the coral animals. The coral animal itself is completely colorless, and it's all the fine differences in the algal symbionts, the zooxanthellae algal symbionts, that give it its beautiful color. Importantly, it gives it 60 to 90% of its nutrition. So without the zooxanthellae, the coral eventually starves to death, or it gets so starved and weakened that its immune system is degraded and it gets diseased and dies. But it'll eventually die if it doesn't have this really substantial nutrient source for itself. That symbiotic relationship is very sensitive to temperature, just 1 degree centigrade. Corals are thought to be the canary in the coal mine, very sensitive, kind of precursors to bigger problems. So the coral, they're referred to as sentinel species or sentinel organisms. They're very sensitive to global warming, 1 degree, and they start to bleach. So these animals have lost their zooxanthellae. Now, if the ocean waters cooled back down within a week or two, they can regain the zooxanthellae and continue to live. But if they're warmed for more than a few weeks, then the corals die and there's no chance to regain those zooxanthellae. Here's the problem. We've globally averaged warmed the planet by 0.85 degrees. So we're now, our baseline temperature is now 0.85 above pre-industrial. So it just takes a small natural climate variability now to cross over that 1 degree mark and bleach corals. And we've had this increasing trend in coral bleaching, the occurrence, the frequency of coral bleaching. And we've lost almost a third of all the corals on Earth are now dead. And imagine if the Brazilian, Amazon rainforest, we haven't cut nearly a third of the rainforest down, we'd be freaking out. We've lost a third of the corals, not just to bleaching, by the way, but to other effects as well. This is the temperature, since the industrial era, and this is, I didn't say this yet in this class, but one of the big refrains, because of all those natural variations like El Nino and the Pacific Decadal Oscillation, the Atlantic Multidecadal Oscillation, you can't take a single year it got warm or a single year it got cold. You can't even take a decade that it got warm or a decade that it got cold. Global warming, human-caused global warming, is a multi-decadal trend. And this is a really strong trend since the 60s especially. It's the multi-decadal trend, and then all this is those climate oscillations superimposed. It's El Nino, it's multi-decadal oscillation, Atlantic multi-decadal or Pacific decadal. But you'll notice here that this was a big El Nino 97, 98, and it put a big spike on global average temperatures. And then La Nina came the following year and it cooled it down slightly. We have since then trended up, and we are now in one of the biggest El Ninos we've ever measured. It will certainly be almost as big, if not bigger, than the 97, 98 El Nino. So you're going to expect right here a big spike in global average temperatures for 2015. You will see all kinds of news articles about 2015 being the hottest, year on record ever in human history. And one of the reasons is that superimposed on this is one of those little spikes, those temporary spikes in temperature. And because of that, you're going to see a lot of reports of coral bleaching in the news as well. It's going to be one of the worst years for coral bleaching because it's a big jump on a 0.85 background that's going to take a lot of ocean waters over that 1 degree mark and cause them to bleach. Okay, so that's global warming. How many people are having, do I want to say this yet? God, we're going to end this lecture on something more positive. So I promise I won't send you out of this room on a big downer, but we got to get through all the down stuff first before we can, we got to see the darkness before we can appreciate the light. So, all right. Acidification. So how many, you guys have heard of ocean acidification? And how many people have done science experiments where they blow in a straw into a glass and then measure the pH, So we all know that CO2, and how many, I have a great story. I love this story. I tell it almost every talk I've ever given in my life, I think, just about. So you know, I was a logger, right? I grew up in a little tiny town of 7,000 people on the Olympic Peninsula, and you know, my brother's a prison guard. My other brother works at a sawmill door plant, and I'm the crazy kid that went off and got a PhD in science. So I go back for Christmas, you know, and I'm like in this kind of crazy like second world or whatever, you know. And so I was back. This was years ago now, but I was back. I think I was still in college, and we were playing Trivial Pursuit. How many people know Trivial Pursuit, that game, you know? So my older brother gets a question for me, and it's a science question. I'm like, yes, you know, I know. I took biology, physics, chemistry, just give, you know. And he goes, what is the gas in soda that gives it its fizz? And I want to add here, he didn't say that because it wasn't the question, you know, it's acidity. And I go, oh, CO2. And he goes, wrong. Carbon dioxide. I go, wait, that's the same thing, C, carbon, O2, dioxide. And he goes, okay, but next time you've got to get it exact. So you add carbon dioxide to a soda, it gives it its fizz, and it gives it its acidic bite. And we've increased the acidity of the ocean by 28% since the pre-industrial era. So, and it's expected by the end of the century will be 150% increase in the acidity of the ocean. The ocean is not acidic. It doesn't have a pH less than 7 right now. It's moved towards the more acidic direction. Let's put it that way. It still has a pH of 8.1 instead of 8.2. So it's, you know, some crazy person says, oh, the ocean's not acidic. It's got a pH. It's like, okay. But we're moving towards acidic, and organisms in the ocean are acclimated to 8.2. And when you move it to 8.1 or lower, you're going to disrupt the precipitation, the ability of these organisms that use calcium carbonate to precipitate calcium carbonate. Because when you increase the acidity of the ocean, you decrease the carbonate ion concentration in seawater. And you need carbonate ion to make calcium carbonate shells. So the calcium carbonate ion concentration goes down as the acidity goes up, or as the pH goes down, however you want to talk about it. This one, I wish you could see these numbers. I was going to redraw those. This is a really kind of powerful, you know, moment right here for you guys. So this whole Goldberg guy, and one of the et al. Authors is Drew Harvell. She's a professor at Cornell, a good friend and colleague. And this is a science paper. How many people know the journal Science, right? So like, you know, when you guys read stuff about anything that has to do with science, you know, I really encourage you to like look at the source and what the source is. Anybody can write anything and make a blog and say anything, you know, and it doesn't make it true. But if it goes through a really rigorous peer review process, a scientific journal goes through, how many people know about the peer review process for like publishing a paper? So you know, you write a paper, you send it in to the editor sends it out to anonymous reviewers, so they can be as mean as they want, you know. And I promise they are really mean. If you've done something wrong, they are going to just like nail you. So you are, you know, you've totally missed. They don't hold anything back. So, okay, you correct a paper, you resubmit it, and they're like, okay, we'll let it through now. So it's a real rigorous. It doesn't make it 100% certain that it's going to be the right, because we're on the forefront. Science is like trying to figure out something nobody's ever seen before. So we do make mistakes, but they're almost, you know, they're really minimized by going through this peer review process and all these anonymous people having the freedom to just rip you apart if they want. And Science is one of the most prestigious scientific journals there is. There's Nature and Science are the two, you know, big giant ones. So I like to point that out. So these guys did I don't know if it was direct experiments or they did some modeling work, but their estimates are that, and I wish these numbers, the projector's not really bringing these out, but this is, well, you can see this, 375. I want to point that one, first of all. So these guys wrote this paper in 2007, and in 2007, so like less than 10 years ago, right? Remember, 180, 280, 380? This was 375. That was the day that when they published this paper, that was what CO2 was in the atmosphere, and now it's just been, you know, 7 years since then, 8 years since that. And now we're at 400. And you can't read this number, I admit you can. 450 to 500, okay? 450 to 500. Corals compete for space. You know, they are benthic organisms and they want to hang on to space and they need to precipitate calcium carbonate to do that. And they compete with macroalgae that don't have to precipitate calcium carbonate to do that. When the CO2 is low and the pH isn't so low, they typically outcompete the macroalgae for space, and we have beautiful coral reefs. And now when we lower pH, their ability to precipitate calcium carbonate becomes a struggle, and the growth advantage and the competitive advantage for space shifts to the algal mats, and the macroalgal mats take over the coral reefs, and we lose the coral reefs. That's at 450 to 500, and I'm telling you guys that it's going up from 2 to 3 parts per million every year. So in 20 years, 2 decades, 20 years, we're going to be at 450. That's where we're going to be. And this is where I say another terrible thing, which is your kids are going to look in a book and they're going to see all these beautiful coral reef pictures, and they're going to go, Mommy, Daddy, like, why can't we go see those coral reefs? And you're going to say, because we don't have those anymore, because we killed it all, And when I say we, this is a big thing I emphasize, and you're going to hear it more at the very end, and because this is high school and not college, and I have parents in the audience, like, I have the foulest mouth you could ever imagine. Not the foulest, but I will get pretty foul, because I get really mad. So you guys didn't cause any of this. You guys were not born, or you're little kids when all this stuff happened. So you were absolved of all of this at this point in your life. But soon enough, you're going to be 18, adult, and then you're going to take ownership for fixing the problem. And I get mad when my generation makes these comments about, oh, millennials, they're so selfish and self-centered, and it's like, we friggin' destroyed the planet, to put it nicely. And we have the gall, we dumped all the CO2 in the atmosphere, we acidified the ocean, we killed the polar ice caps and the coral reefs, and we have the gall to say you guys were selfish. By the way, did you know that 90% of the biggest, best fish in the ocean are now gone? My generation and one or two before me took 90% of your fish out of the ocean, 90%, and left you with this little 10%. So, yeah, think about that. So, by the way, half of all the streams in the United States are now considered unfit for aquatic life because we've poured a ton of nitrogen fertilizer onto the grounds to grow corn to make all our cows that put manure. So, my generation has no right to speak about selfish self-centeredness. I do say this also, that you didn't do anything to make this problem, but you're going to be your generation that's going to have to fix this problem. And the analogy I use is, every so often a generation gets called upon to do something really extraordinary, not fun at all, but extraordinary. And the generation that was 18 or so years old back in 1940 when World War II started, they didn't create the geopolitics with Japan and Germany, but that generation had to step up and fight a war and fix the mess that the previous generation made. You guys didn't make any of this problem, but you're gonna be the ones, I promise. It's the 20, 30-year time scale. That makes it your generation that's gonna have to fix this problem. So get ready for it. You're gonna be in for a real ride here in another 10, 20, 30 years. It's affecting oyster populations already on the West Coast. And there's a lot of work going on in oceanography because not all the organisms at the base of the food, but the microscopic plankton, either the phytoplankton or the zooplankton at the base of the food web, lots of those organisms use calcium carbonate for their protective shells, and these are going to either be slowed down or unable to grow at all. In fact, some of these plankton are expected to not be able to grow at high latitude Arctic Ocean waters within several decades. So it's that soon where a lot of these organisms are going to stop growing completely. Oh yeah, if you weren't freaked out and bummed out, yeah, how many people are freaked out and bummed out so far? Okay, good, because if you're not, you're probably sleeping or whatever, I don't know what's your problem. So, extreme weather, I think we already know about that. We have forest fires now, we've got flooding, and we've got droughts, and we've got everything, and we're only at 0.85, by the way, and not the 2. These are NASA scientists put a paper out that said their climate models predict that we could get forget California's drought of like 5 or so years, we could get droughts that last for decades in the coming future. Typically, the rule of thumb for global climate model futures are places that are typically dry normally are going to get a lot drier, and places that are typically really wet are going to get a lot wetter and flood a lot more often. Oh, and if that wasn't, this is the last bad slide, I swear we're at the very end of bad slides. It's going to get better after this. But food security is a big deal. People have modeled, like a lot of the crops that are being grown today are near their thermal maximums for their yields, and we raise temperatures any higher, their yields will start to drop. And there's real concerns about declining crop yields with global warming at the same time that we have increasing human populations on the planet. Okay. So, prospects for changing things. Yay, so how close are we? What time is it, guys? Don't tell me it's... God dang it. We stopped, okay. I'm gonna go. How much longer? This is one of the most important slides, and then I'm gonna go as fast as I can the last few slides. We're pretty close to the end, by the way, and I might get it straight up. Scientists can, what we put in the atmosphere stays in the atmosphere, essentially, for 10,000 years. 10,000 years. So that's double recorded human history. Recorded human history is 5,000 years. So 10,000 is twice as long as we've got recorded human history. So it's a long time. It's essentially forever. So we can back calculate how much CO2 for all the rest of humanity. 10,000 years is the rest of humanity. We can burn 500 gigatons. We can either burn it today or we can burn it 10,000 years from now. We have 500 gigatons to burn and not go over 2 degrees warming. 500, and that's it. It's fixed. We can burn it. This generation can burn it, or the next generation can burn it, or whatever. But nobody, the cumulative effect, nobody total gets to burn any more than that. So that's it. And we're currently burning at 50 a year. So if everything we burned went in the atmosphere, we have 10 years, and we're going to cross 2 degrees. Half of it goes in the ocean or gets taken up by land. So we have 20 years at full speed, 50 gigatons a year, before we hit that 2-degree limit. And if we cross it, there's worry that we're going to be in big trouble. So we can either, the big question, the big decision we have, our government leaders have to make. So I guess I want to emphasize, really smart people have worked out really good plans to get us out of this problem. There are technical solutions for all the stuff that I've talked to you guys about. Mostly. Some of these things might be lost. The corals might be lost, actually, I have to say. But the worst of it we can avert with a plan that's really well worked out. We just need the leaders to follow the plan, and they haven't done that so far. So here's the choice. 50 full speed ahead for 20 years, and then just go to 0, like instantly. That would hurt. Or we can make it last. We have 500. If we cut emissions today in half, we can make it last 40 years. 40 years would be really easy to move us from our fossil energy carbon system to a renewable system. That's doable. So cutting emissions as quickly as we possibly can right now is really going to help us a lot in the future, because we can't, there's no way to lie with numbers here. That's the numbers we face. You'll hear words about gap, and that gap, this idea of gap, it's a kind of a UN term, I guess. It's the game plan that we need to follow and what we actually are following, and the gap is the difference between them. So people have worked out a plan on how to get us down to 0 carbon emissions, to decarbonize, you're going to hear that term a lot, decarbonize the planet, our energy system. And we currently have a gap between what we need to do and what we're actually doing. This is Christina Figueres. She's the UN climate chief, and a decarbonized world is now irreversible and irrefutable. So don't get this idea that we just have to slow down and ease up or get a little bit more fuel efficient. We have to go completely off fossil carbon energy. It's basically, we are going to do this because frankly we don't have any other option. We can't get around the hard fact math. We've got 500 or we cross 2. And so we have to decarbonize. And I'm going to kind of, because I know I'm out of time, I'm going to stop it right here and just say I think I'm going to say one last thing. Yeah, I mean, be aware of this big climate talk. The commitments that have been made so far for this talk will not keep us under 2. But it's the biggest step we've ever taken in human history to figure this problem. I claim you should pay attention to these climate talks. Write your congressman and tell them you want these climate talks to go through properly and all that. It's the first time that we've made serious commitments to reducing carbon emissions. Not enough to take us below 2, but it's the first nice big step. It's not the full step. And I'm going to end it with that. So I get into this big thing about you're informed. You don't have to go out and you have to write your congressman and tell them what you've learned. You now know more than all that. But I will end it with this great moment I had. So I would listen to this big downer on a radio program where this guy went through climate change, boo, 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 down, down, down. It was like, oh my God, and somebody at the very end of that hour-long, killer lecture, on the radio is like, how do you stay positive? And he goes, I'm totally positive, there have been two major revolutions in human history. There was the Industrial Revolution, and there was the Agricultural Revolution and the Industrial Revolution. And I get to be alive to see that third major revolution where all of humanity goes from a carbon-based energy system to a renewable system. And I get to see it. I'm stoked. And as far as the future goes, I tell lots of students, we're in 100 years, so we're going to definitely go to renewables or we're going to not be here. And two quick things. So how many people have seen those old documentaries about World War II? Like where we were in the Great Depression and we started World War II, and we were like throwing like these battleships were sliding into the water like 5 a day, and these like bombers were coming out of these aircraft 10, 20 a day. Like we were crazy. We went nuts and built all this stuff. And if we did the same thing and built windmills and solar panels, we would be partying. Like everybody would have a job. We'd have an economy. It would be awesome to build this stuff. And I'll end it with this and say, in 100 years, when we have solar panels on all the buildings and all the houses, we have wind turbines, and we have no pollution, and we have free solar energy, you're going to look back and see these news articles and these news, videos of the BP oil spill or these trains blowing up, these oil trains blowing up, and all these people getting sick. You're going to go, these people were such primitive people. Like, they lived in such shit, So the future is not this, it's going to be a bleak light bulb. It's going to be this gleaming, awesome thing that we're going to look back at these times and go, what a bunch of crap these people put up with. How could they have done that? So anyway, we'll end it with that. Write your congressman. These slides, you can get to these slides if I send them to you, but get to these slides, and there's some links there on what you can do to contact Congress and that kind of stuff. So anyway, sorry, I always do that. I'm always talking way too long. So I know some of you have to go. Who has to go right now instantly? Who wants to stay for the last few slides? But why don't we just stay informed? I don't know what to do with you guys. You're not saying anything because you don't know you're supposed to say anything. Whoever wants to leave right now, leaves right now. And if people want to see the last few slides, so we'll take a 5-minute break. Those who have to get out of here, get the heck out of here. And those who want to stay, and if nobody wants to stay 5 minutes, it's not going to hurt my feelings, I swear.
Keep going. Good.
Okay.
Still get up and go if you need.
Okay, I'm just going to keep going. Okay, so how do we do CO2 emissions needed? Well, this is one of my, this guy gave a talk in my class last year. He's a green venture capitalist, so he's a capitalist. He invests giant amounts of money in green technologies. And I have to say, I'm kind of like a liberal socialist kind of guy, and I kind of like feel like big corporate whatever can be kind of mean to the average person. So I have that in me, and so there's this term. So there's this term called the magic hand of capitalism, that it forces you to make a pencil the most efficient possible way, and it lets you make like a 2-cent pencil because people like calculated out how to get the wood and how to get the rubber and how to get the metal, and they figured out how to do it the most efficient way, and capitalism, profit-driven capitalism, gives you like the most efficient way to make something possible, right? So how many people have heard that kind of idea before? All right, so I always feel like, that's exploitation, you're going to make the wages real, blah, 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 whatever. So that's me, but I have to say, in this situation, so people ask me, like, well, what do we do? Like, do we build wind first or solar first? Or do we do plug-in electric cars first? What do we do? I don't know. Which one comes first? And I don't know, Maybe some people really have thought this through, but I don't know. But a carbon tax is the easiest way to fix this problem. And I call it, the same magic hand, If you put a tax on carbon, and this is called carbon fee and dividend, which is a revenue-neutral tax, because no conservative is going to let taxes go up. They're going to scream bloody murder. So the idea is this. You tax carbon at its source, fossil carbon at its source. Everything that has some fossil carbon in it, whether it took the energy it took to make this price is going to go up. It's going to cost more, right? All that money that got collected in taxes, though, is going to be given back to every single citizen in the country, like a $3,000 check. Everybody gets a $3,000 check. If you're a decent human being and you bought a smaller car and were more efficient with your carbon dioxide, footprint, you will actually make money. The $3,000 will be way more than you paid for all the stuff you bought that year. And if you're a big fat pig and you buy a Hummer for driving, then, by the way, those guys, I mean, then you're going to end up spending a lot more money on the gas and the tax that went into building that big fat Hummer. You're going to end up spending way more than $3,000, and so you'll get your $3,000 check back, but it won't make up for all the piggy sort of behavior you had all year long. So everybody, you know, with this in place, everybody's going to be like in their basement figuring out how to make like things as low a carbon as they possibly can. Like the magic hand is going to work to get carbon costs, you know, reduced more and more and more. So, yeah, okay. Then there's two kinds of geoengineering. Solar irradiance modification is a terrible idea, but it might be, people say it might be a last resort that we have to go to, which is to dim the earth, put sulfates in the stratosphere and not let as much solar energy come into the earth. And that will, it's like a volcano going off. It'll temporarily cool the earth. It's cheap to do. We have the technology to do it. It doesn't do anything about acidification. And where's it going to end? You know, like we're going to be in this dark world, you know, 100 years from now going, well, we got like 1 million parts per million CO2 and we're like bumping into stuff because it's so dark. I mean, I'm exaggerating a bit here, but it's a pretty, and then there's all these other issues about these kind of moral issues, like when you start modifying the climate like that, you know, with the sulfates, you're going to man-made, humanly alter like rain patterns, you know, so is it morally just for you to put that stuff in the atmosphere one country and make another country go into a drought or make another country have massive floods, you know, so there are all sorts of moral questions with that are bad. Something that's completely moral question-free is carbon sequestration. If we can sequester carbon dioxide out of the atmosphere and then store it somewhere deep in the earth, then we're removing carbon dioxide. That is a completely cool way to do it. And there's some technologies that can take CO2 out at smokestack kind of sources where CO2 is high. They haven't been developed out into, you know, broad scale. They're like in demonstration mode. And then there are also CO2 captures at ambient CO2 levels, and they're slow acting, they're not very efficient, and maybe with some time and technology we can get those things more efficient to start pulling carbon dioxide out of the atmosphere. The cost of doing nothing, you know, people say, oh, it's going to cost too much, oh my God, if we don't do anything, this is nature, so again, it's not like Jim Bob's, you know, website, you know, that put this number out. You know, it was 60 trillion, so it's a lot of money. Don't count on our leaders. That's where I tell you guys, if you don't step up and ask for this change, it's not going to happen. That's my strong, firm belief. I have some examples here of, you know, everybody knows the history about women's right to vote in this country. Some president didn't wake up one day and go, wow, that seems so unfair to women. I think I'll give them the right to vote. You know, like, no way, man. Like, people took to the streets and said, that's totally unfair. We want this changed, and African Americans, civil rights, you know, African Americans and others, you know, took to the streets and said that's not fair. Some president didn't wake up, and I promise you, some president isn't going to wake up and say, "Oh, I want to make a sustainable world for everybody," you know, I'll make it. No, you guys are going to have to ask for it. I promise you, if you don't ask for it, you're not going to get it. And this is the story of, you know, the microwave. I heard you guys got a microwave, 2 of them actually, I heard. And because you asked for it, you didn't